All right, so as we get ourselves ready for this quiz, there are going to be some questions on here that basically are asking you to explain how or why you do certain things. So like for instance, when referring to rational expression operations, the four basics, add, subtract, multiply, or divide, when do you need a common denominator? Only when you're adding or subtracting. When you're multiplying and dividing, our number one thing is to be canceling stuff. Factor it and cancel it. Here I've got to have an LCD in order to be able to make these things work. So only those two. However, no matter which of the operations we're using, when we're trying to simplify any rational expression, my first step or first question always needs to be, can I factor anything? And again, when I say factor, it can be as simple as taking out a common factor. It can be as crazy as doing a difference of squares, a diamond, slide and divide, mental math. There's lots of things that can go on. But can I factor anything? Is there something I can do before I start canceling or building that LCD? Now, in this next part, hopefully we keep it simple. What are the LCDs for the following rational expressions? Not solve, just what's the LCD going to be? And so, on this first one, in my denominator, because that's really the only part I'm paying any attention to be perfectly honest, I'm not paying any attention to that stuff at all. So when I look at these, I'm like, there's no coefficient values, there's no single variable terms, so my LCD would just consist of my two quantities in the denominator. That's it. If I have a coefficient and I have a single variable term, they each would need to be part of it. Now, does that mean every time I can just multiply the two things together, because we've done that in the first two, and say, oh, I'm good, I'm going to make this work? Not necessarily. This last one goes back to what we were talking about here in number 2. When I'm looking to simplify, I always want to say, can I factor something? Because if I can, I need to, and I usually just scribble that old denominator out so I don't get confused. But when I'm looking for a least common denominator, each unique quantity is part of that, but the only time I would need to use squared on something would be as if one single fraction had two of them. So just because I see 2x minus 8 doesn't mean I need 2 in my LCD. Okay, really I only need 1 if I want it to be the least. But there again, just looking for the common denominators on those, not looking to solve the entire thing and simplify. However, when we get to 4, that does become the case. And again, this was the type of thing I was talking when I had all the Band-Aids all over my face from my regular Algebra 2s the other day, and hopefully I'm going to have 0 Band-Aids after this next one. Now, as long as we don't do anything silly like think we can cancel these right off the bat. That is a Band-Aid offense. Always look to see if you can factor something first. That's going to keep you out of trouble. Because originally that denominator was bonded by the plus. I couldn't cancel anything. But once I factor it, now whatever's not in the parentheses has weak bonds. That's fair game to reduce. And I can reduce that because I've got my exponent rules that tell me I can just subtract, or I could cancel. 2 minus 1 is 1. The larger exponent's up in the numerator. And then again, why I always, when I see plus or minus, put parentheses around my terms so that temptation isn't there to want to cancel these x's and drive me out of my mind. So factor first, then reduce, then we go back and see if there's anything else we could do. When we get up to 5, again, I see pluses and minuses, so I got to do my factoring work first. No canceling right away. I've got a difference of squares up in the numerator. And then in the denominator, got a little bit of factoring to do here. All right, let's see. 7 and 1, and both negative. This is the point, after I've done my factoring, this is where, okay, now if I see things that are identical, I can get rid of them, and then whatever's left is going to be my solution. But again, the key is factor first, factor first, factor first. Unless, of course, there's nothing that's factorable anywhere. Those are all, single terms. Now, everybody's got their own way of doing this. Some of you feel absolutely comfortable starting to go to town canceling stuff right away. Me, it drives me crazy because then I forget what I canceled and what I didn't. So what I normally do is I go ahead and I multiply straight across and get it down to one fraction. Then I go to work doing the other stuff. And especially with all the fancy things we've got working on calculators anymore, if I wasn't sure what 192 over 100 reduced to, or I thought I was going to use too small of a number, I can always use my math enter to get my reduced fraction, at least with the numeric part. Then I'm going to use my exponent rules. Oh, I only have x's in the denominator. Okay. And then with my y's, I'm dividing. When I divide, I subtract the exponents. 5 minus 1 is 4. Bigger exponents up top. That's where my y to the fourth is going to end up. And like I said, if you're comfortable canceling and stuff like that before then, you can. I just like seeing things in one fraction a little bit better than two. Oh, let's see here. Division. Division means that fraction right after it, we're going to take the reciprocal. So as I'm rewriting this and looking to see if I can factor anything, that division will become multiplication when I take the reciprocal of my second fraction. And again, since I'm multiplying, I do not need a common denominator. I just want to start canceling and reducing things. And again, some of you may feel comfortable enough to go ahead and do some other things right away. I like kind of reorganizing once I have checked out any quantities I could cancel, and then it's visually easier to me to see, oh, okay, well, got this 4 here. 6 minus 4 is 2, but my bigger exponent is in the numerator. And I can get it down to the end. But if you see that in the step before, like we've said before, that's fine. You can do it there. It's not like there's an absolute order that you have to do things in. The only thing I got to remember with the division, keep on taking the reciprocal of that second one. So flip that over. And again, I like just multiplying across. To me, one just works easier than dealing with two. But I do have to remember to simplify it, of course. Both divisible by that 28. 5 minus 4 is 1. Bigger exponents in the denominator. And I'm good. So on all of these up here, no common denominators needed. That's kind of mean. After number 3, you had to figure them out, but we'll get to one like that. And then last one, nothing to factor in the first fraction. Nothing to factor in the second one except remembering that's in the numerator. That's why I put the 1 in there. Normally if I get one fraction, I make everything a fraction just so everything looks alike. And then I noticed the last one, it's division, so I need to flip it. And there is my one factorable binomial term. At this point, again, once we're in multiply, we can go ahead and cancel our like quantities. I got an x left in the numerator. I got a 2x plus 5 left in the denominator. And I'm good to go. All right, now, with a reminder, okay, add or subtract expressions. You need a common denominator. Well, if I only have one fraction there, even though I guess I could turn the 7 into a fraction by putting it over 1, my LCD is just going to be y. So I put the y there. Well, the x is already over y. I don't need anything else. But when I get to the 7, I'm going from 1 to y. Well, I'd have to multiply by y to get there. So that y also has to end up in my numerator. And I can always double check these. Because if I were to look at this and then go, oh, if I cancel out the y's, oh, I get the 7 back. Okay, it's the same. And at this point, with that plus in the middle, there's nothing I can cancel. That's all I'm going to be able to do. I can't whack the y's back out. That will not help me. Well, it wouldn't be legal for us to do mathematically either. So when you're building these, and you can do this in a couple of different ways. If you feel comfortable just going to one fraction right away, you can. If you don't, the other way you can look at it is you can build two separate fractions. Okay, I've already got there what I have. And you just ask yourself from fraction to fraction, what do I multiply by to get from 3 to 3y? Well, I need a y. How do I get from y to 3y? Well, here I need a 3. And then I just simplify the numerator and get to my answer that way. You're doing the same thing either way. It just depends on if you're comfortable in one fraction or if you'd rather do each separately and then put them together at the end. I'm perfectly fine with either. On 12, no coefficient terms, no single variable terms, so my LCD would just be both of my quantities. So for this one, we'll go back to the one fraction format. I'll do number 13 the separate way so you can kind of see things again. But here I'm going, okay, how do I get from here to here? Well, I've already got the x plus 3 part. I need an x minus 2. And then for my second fraction, I already have the x minus 2 part. I need the x plus 3. And I can't just keep this. I do need to simplify it because you never know. Something may reduce again. So let's see here. So I'd have 4x minus 8 over here, 2x plus 6 over here, 4 and 2 is 6x, negative 8 plus 6 is minus 2, and it doesn't look like I'm going to be able to cancel anything. I do notice I could take a 2 out of each of those, so I guess I'll do that just to play it safe. But, alas, nothing cancels still. So actually, either of these answers would work okay on number 12, since I got fortunate and nothing would cancel anyway. But if something would sometime, that's why we usually want to make sure that we do that anyway. And then finally, here, if I started counting by 5s and counting by 10s, the first value I'd get in common in both lists would be 10. Can't forget my x. If we go the two fraction system, I ask myself, fraction by fraction, how do I get from the old denominator to the new one? 5 times 2 is 10, and I need the x as well. You're basically saying this times what gets me to this, and that's the 2x. And then here I got the 10 and the x already. Nothing else to put in. Multiply those guys together, be 6x squared plus 4. And this is the situation why we always do like we did in 12. Even though in 12 nothing canceled, about the time we don't do that, something will. For example, I can take a 2 out of each of those factors. And now, whatever's not in the parentheses is fair game to cancel. I can reduce 2 over 10 some more to 1 over 5, which would just leave me with my quantity over 5x. So take that extra minute when you get to the end. Really take a look at your numerator and denominator and say, is there anything else I can factor, cancel, reduce, something like that to make sure that you get all your points. But the big thing here is finding that common denominator first. To the back. More to do. All right. Still adding and subtracting. Still need a common denominator. Still want to factor any denominator pieces that I can. So I start to work this. Like I said, I'll go back and forth with our systems here. And I notice with my first fraction, I already had the x minus 7 and the x minus 2. So I don't need anything more here. But my second one, I already have the x plus 2, but I do not have the x minus 7. So I build that in and distribute 5x plus 2x is 7x. Negative 1 minus 14 is negative 15. And once those denominators are the same, I don't cancel them unless I get to the end and find something. Not really. Let's see here. 15 is kind of my gimme problem. At least it should be. Denominators are already the same. Nice. Less work. But a lot of people just do 6x minus 36 and then leave it. I'm like, oh dear, why would I give you one where you just write it down? Or they try to cancel the x's, so let's put the parentheses so we don't forget. Every time before you quit, can I factor something? Uh-huh. And amazingly enough, when I actually factor, they cancel. So all that just to get 6. Yes. That's why I always take that one last look at the end to make sure. So one last one till we get into a little review down here, because we always got to make sure we don't forget the things from the past. My LCD, again, is each different set. I don't use 2x plus 3's because there's not 2 in a single fraction, excuse me. So here I'm going from my old x plus 3 to my new x plus 3 and x plus 4. I already got the x plus 3. So I need the x plus 4. My second part of the fraction, though, doesn't need anything. But here's the catch, and be careful. With the minus, that minus distributes to the x squared and the minus 6. And it's that distribution of the minus 6 that everybody seems to forget when they're doing one of these. I'm going to be a proponent in this one of taking my time. So I'm going to take one extra step here where I distribute my 8 and I distribute my negative through. And then we'll combine like terms. I don't think that's going to factor anymore. So not every time will something factor. I mean, you notice on 14 and 16, nothing happened when I got to the end. 15 had a little excitement, though. So then, like I said, we're going to throw some review stuff back in because we don't want you forgetting about it when we've got quizzes and tests and things coming up, whereas they'll keep showing up. So for our review section, getting ready for this quiz, we want to solve using logs. So remember, E and natural log are inverses, and also a log and its base are inverses. And here's the thing that people have been getting mixed up when I've seen anything get missed, because we don't miss a lot on things on here. I can't just divide by the 0.3. I actually have to use the log of it. And this usually is not the place where people get in trouble. The place where we normally end up having trouble is when we're actually trying to solve this in a minute. Because I'm not going to punch that in my calculator quite yet, because I don't want to round for this and then have some other screwy thing happen. So I need to add 8 to this. And I'm going to put that inside of the parentheses so I'm not tempted to try and make it 19.3. Aha! Good catch. That's plus 8. I was trying to think ahead. Thank you. That'll be minus 8. Now that would have gotten kind of ugly. So when I go to punch this in, and I'll pop it up over here so you can see, remember, with your logarithms, it's always the log of the physically larger divided by the log of your base. It has to be done in that order or you'll get a different answer. So the log of 11.3 divided by the log of 0.3. The of divided by the base number, then minus your 8. Do it in steps. And I believe the instructions on the quiz will say go to the nearest thousandth. That's why I am going to do that here. But I got to keep that order set. If it looks gorgeous yet I flip these around, I'm going to get a different answer and it's not going to be right. But it's always about isolating either your of base or your e base. Not your e bay, but your e base. So in this case, I can divide by the 5 because it's blocking me from getting to that e. And I have to do that first. I can't do the natural log first and ignore the 5s there and then go back and deal with it later. You've got to work from the outside in. Because once I get that e set, I can use the natural log. And again, hang tight on popping into the calculator quite yet until we get that x value alone. So what I want to shoot for here is the natural log of 30. Don't forget to close your parenthesis. And we're set. So get our value, get that circled, and we're off and running. Simplifying, don't make too much of this. Again, I'm not multiplying, it's just a minus, so I'm basically just combining like terms. So here, 9 minus 1 is 8. 5i minus a negative makes it plus. So 5i plus 2i is 7i. That's as far as I'm going. There's no i squareds that I can turn into negative 1s or anything else like that. So I just write it in standard form and I'm good. 20, y equals x minus 5 squared minus 1. What's the vertex? Ooh, remember, when we're in a form like this, where my vertex is at hk, I'm basically just taking the opposite of what I see here, so 5, and then keeping this value. So 5, negative 1 would be my vertex. You could find that punching it into the graphing calculator, but it takes some more time. And then my axis of symmetry is always just going to be the x value of my vertex. And I have to have x equals. Because unlike when some of you, when you're doing like an x-intercept, want to put x equals, which makes it a line, this is a line. I do want the x equals part. Okay, but like I said, I could pick that up off of the calculator, but if I know it off the top of my head, it's even better. All right, solve the quadratic. Let's see if we can factor it. If we can, that's even better. I need a negative and a positive. Negative number is going to be bigger. 10 and 5, okay. Solve. What are the actual x values? Whoops, I got a little ahead of myself over there. That make this true. Set each of those quantities equal to 0 and knock out a couple of answers. So we're kind of going back to yesteryear here, even though the factoring is going to keep right on coming here. And then finally, 22. For me to be able to use my bases, they have to be the same. 125 is in disguise. That's not really 125 at all. It's 5 cubed. Well, why does that matter? Because once the base number is the same at 5, I can just take the exponents and set them equal. And now we're back to Algebra 1. Get all my x's together. And get my answer. That basically covers everything that's going to be on the quiz. So you've got a pretty good feel for things as far as that goes.